Integration of Internet of Things and blockchain to increase humanitarian aid supply chains performance. Lessons learned during the pandemic. This work is presented by Daniel Arias Aranda from the University of Granada in Spain. Let's start with an introduction. The different epidemics, outbreaks, and pandemics occurred in this century, like SARS outbreak in 2002 until 2004, swine flu pandemic in 2009, Western African Ebola epidemic in 2013 until 2016, among others, have increased the interest on supply chain security by receiving more attention from researchers focusing on different aspects related to the impact of specific actions in emergency situations. The relevance of supply chain management, also known as SCM, for improving business response capacity in the current pandemic situation has been highlighted by academia and professionals. Given this scenario, integrating IoT devices with blockchain technology offers a prolific prospect to dismiss several of the flaws in humanitarian aid supply chain, or HASC. But the question is, what is a blockchain? Okay, a blockchain can be considered a distributed database that is organized as a list of ordered blocks, where the committed blocks are immutable. This is an evolving technology with 4 technology waves. In blockchain 2.0, smart contracts were incorporated and developed beyond cryptocurrencies. Blockchain 3.0 expands the application in areas such as health and IoT. Finally, blockchain 4.0 is under development, and it should incorporate artificial intelligence. In the current blockchain 3.0, the combination of blockchain and IoT is grounded on decentralization in order to guarantee transparency, resiliency, and security. Regarding humanitarianism, COVID-19, and supply chain management, we can say that during pandemics, humanitarianism plays a fundamental role by encompassing different economic standardizations and coordination. In addition, constant monitoring of all actions is crucial to ensure supply chain resilience. Flaws in these 3 issues drive to critical failures in achieving crucial milestones of humanitarian action due to delays, shortages, or resources, as well as duplicities or undersupplied areas. The COVID-19 experience or crisis has brought out the relevance of SCM for relief interventions. The most relevant HASC distinctive features, especially for pandemics such as COVID-19, are as follows. First, projections of demand in the initial stages require continuous adjustments due to the uncertainties derived from crucial variables of the pandemic, which are initially unknown. Also, flexibility and agility become crucial priorities. Second, HASC design and maintenance need to be based on resiliency in order to ensure all essential streams of basic goods and information contemplating particular requirement. Third, HASC design must involve all different organizations and institutions to become actors in the pandemic. The Internet of Things, IoT, and blockchain. The Internet of Things enables numerous devices to remain permanently connected to the network and transmit data without interruption. Centralized server client models are at present the backbone of IoT systems. These centralized models have the benefit of controlling the information generated by the devices and having very energy efficient clients. However, one of its major handicaps is the impossibility of flexibly exchanging data by the devices. The number of IoT devices is steadily growing, so that the effort for data management is increasing simultaneously. In order to overcome security challenges, blockchain technology has the potential, since it's a distributed database that registers and saves all transactions between different members of a network. The integration of blockchain technology with IoT will allow the process of collecting the information provided by the devices in a decentralized manner while reducing the cost associated with maintaining large data centers. The different blockchain characteristics are as follows. There's a ledger or database of transactions. Then we talk about immutability. Mutability ledgers are created through blocks of data in a way that once two parties have agreed to a transaction and recorded it, it can never be modified. Transactions are cryptographically secured using hashes and digital signatures to secure the chain. Also, we talk about decentralization, as blockchain is not free from scalability problems, and in fact, the actual technology state, it isn't as scalable as a centralized alternative. Next is anonymity. It is not a compulsory characteristic of blockchain, but it can be implemented when it is considered a value feature. And we have improved security. The possibility to tamper with the ledger is very costly and or resource intensive, and there is no single point of failure. And finally, increasing capacity. Blockchain, the combination of blockchain and HASC, it's really interesting because it's useful to generate trust among unknown suppliers, customers, and or service providers. HASC requires a coordination of multiple parties, processes, and assets needed, and the resolution of disputes also is expensive. Blockchain can prove authenticity and ownership, as well as save time in those cases in which multiple serial steps of paperwork slow things down, such as supply trade documentation, supply chain finance, etc. Other blockchain applications are those ensuring trust in recalls, change of custody tracking, provenance, auditability, and so on. Although blockchain can build trust by itself, when smart contracts are incorporated, the trust in blockchain is reinforced. Smart contracts can be defined by a mini series of milestones that need to be fulfilled so that contracts are completely satisfied. Those milestones can be double-checked through IoT at the delivery stage right before transportation by fulfilling requirements like characteristics, quantities, reception, temperature, storage, etc. For HASC, in the context of the COVID-19 pandemic, the implementation of blockchain with IoT implies location awareness, self-reporting, auto-correcting, and interoperability. HASC goals involve increasing speed and flexibility as well. What is the model for blockchain and IoT implementation in HASC? Okay, first, regarding payment management, those current payment systems involve various intermediaries. Blockchain and IoT allow instant payments. Regarding humanitarian action control, blockchain and IoT technology allow ex-ante and ex-post control of collateral humanitarian actions. Regarding monitor and correct inefficiencies, blockchain and IoT technologies generate a broad range of possibilities to correct inaccurate and or inefficient action. Regarding compliance enforcing as well, and finally, the cryptographic security of identities. Different real identities can be associated with cryptographic identities through blockchain. We propose here an integrated model with a first phase, which blockchain and IoT are applied only to ensure the supply in good conditions. The second phase, with other resources, includes other resources from pandemic management like tests. In a third phase, the transfer of infected and the census of the healed and deceased will be added to the system. After disaster, actions sometimes are even more important than actions performed during the disaster. Blockchain and IoT can help to determine which closest warehouses can be accessed to maintain flows of such goods, and for how long to optimize new orders to provide to providers and rerouting in case of need. In addition, medicine distribution can benefit from these technologies by ensuring the food reaches the most needed victims. The stages for action as follow here. First, during the prediction stage, mitigation and prepare activities are deployed by incorporating all structural measures. Then the second is the warning. Then we have emergency relief. Fourth is rehabilitation, and fifth is reconstruction. This final stage involves all structural and non-structural actions, commencing through threshold, the impacts of natural hazards, environmental degradation, and technological hazards, as well as all efforts to restore the living conditions previous to the pandemic. What are the main conclusions? First, the rapid implementation of IoT and blockchain in HASC is conditioned the technology absorption capacity of the different HASC network central nodes, especially government agencies and pharmaceutical companies, which take a central role in fast emergency relief. Hence, mitigating the risks associated with novel technology require regulatory frameworks that ensure secure deployment of all the blockchain and IoT potential. Second conclusion involves the lack of mutual knowledge obstructs the development and implementation of information and communication systems that can guarantee transparency, reliability, security, and process integrity. Also, the joint use of IoT and blockchain can overcome this. In fact, the lessons learned from the first stages of COVID-19 crisis points in this direction. The third part of the conclusions are as follows. Both technologies offer plenty of opportunities of scalability and security and their cost-effectiveness perspective. IoT allows, through affordable devices, to collect plenty of information from the environment that can result in major advancements in life-saving and restoration of living conditions previous to the disaster. For HASC, a gradual implementation process needs to be developed, starting with those challenges with highest cost-benefit ratio, considering technology evolution when applied to warehouse management, traceability, and tracking. What are the main limitations of this study? First, of course, IoT and blockchain will not solve all HASC problems. COVID-19 has proved the large number of errors and highlighted the different criteria that underline the HASC implementation in different countries. HASC is sometimes under pressure of corruption in many situations. IoT and blockchain can help in developing trust and cooperation, creating transparency, but for solving these issues, a broader redefinition of HASC is crucial. Our main future lines of research should focus on the development of optimal platforms to implement them in HASC or regulatory policies to ensure an optimal implementation of these technologies. Okay, after this presentation, I want to thank you all for your attention. Again, my name is Daniel Arias Aranda from the University of Granada, Spain. Thank you very much for your attention.